AS-200L. Main concept, your first step in multitasking. Soft work pusher, cut-in check, data chart interlock, anti-thermal navigator AI. All these four unique technologies is a standard for this machine. Hello machinists, I'm Shogo Nakamura from Nakamura-Tome. Today I'm here Mexican Zawa. It's our local show. I presented this machine, AS-200L, for many guests. This time we prepare new demonstration, new machining, so new software presentation for this machine. And today I share all our presentation contents for AS-200L and YouTube subscribers. First of all, AS-200L. Main concept, your first step in multitasking. It's very simple, easy to use. It's actually best machine when you start multitasking. So, Mr. Ishiyama, please come. Good morning.
Morning.
How are you?
I'm good, thank you.
Okay. Firstly, Mr. Ishiyama, so can you bring your sample workpiece? Wow. Everybody, Mr. Ishiyama bring us big sample workpiece. How much diameter?
290.
290 millimeter. So this machine, AS-200L, so maximum turning diameter is 290 millimeter. And how much length about that?
570.
570. That is the maximum length of machining in AS-200L. Wow, what a big and long workpiece. We can loading AS-200L. However, machine size is very compact. That is a key point for AS-200L. So because always the factory area is limitation. Many customers request us, so this small space, can we do install the machine, or the machine also need to make many variety of workpieces, small diameter and big diameter and short one and long one. So we developed AS-200L. Thank you, Mr. Ishiyama. So can you open the door? So this is AS-200L inside the machine. One tower and two spindle. It's very simple configuration. And we never call sub-spindle on the right main spindle. Of course, spindle box design are different. However, because left and right spindle have the same structure, we aim to design similar rigidity. We look at the turret. This turret have 12 station turret. However, you can see the number 24. Which means we have the function half indexing, and we use a servo motor for indexing. So we have the positioning between stations. We can put the many two like that. Also, axis-wise, this turret have three axes: X, Z, Y axis. X-axis, Z-axis is suitable for turning, and Y-axis is very suitable for milling operation. When you use this machine, please consider about lathe, machine center. The many process combined to one multitasking machine. We always propose for customer from material to complete parts by just one multitasking lathe. So Mr. Ishiyama, today you already prepare nice demonstration of machining. Yeah. Okay, let's show. Now we checking material and start for machining. We start the turning process. So cutting depth 4 millimeter.
Yeah.
And how much is the cutting condition?
Cutting speed is 150 meters.
150 meter. And how much feed rate?
Feed rate is 0.32.
Oh, it's a high cutting condition.
Yeah.
And very stable and powerful machining. Wow, it looks very calm. No much vibration on the cover. That's nice. So next one is how much diameter?
Cutting depth is 5 millimeters.
5 millimeter.
Yeah.
Wow, you are a challenger. Everybody, such kind of the heavy turning process. However, we show very stable machining for high cutting load condition, because always customer want cut many variety of material. Sometimes we need to cut half material, and then cutting load is high, but need a stable machining. Also, when you use a new tool for machining, so sometimes you need high cutting condition. At that time, also with high cutting load, no problem, it's very stable machining. It means low limitation, easy to use. That is good for customer. Okay, everybody, next is the grooving process, another turning process start. How much the width of the groove?
6 millimeters.
6 millimeter. Oh, that is a nice demonstration. Please look at this slide. We have X slide here. You can see this X slide is a box way slide. we adapt for this machine hybrid stride design. Z-axis, Y-axis, we use a linear guide. However, X-axis, we use a boxway stride. We do scraping and we provide boxway stride for X-axis. Why? Because X-axis, we need stable machining and with high cutting condition. So we need adapt boxway stride. Z-axis, Y-axis is very important for positioning, speed, that we adapt the linear guide. That is hybrid stride design. Next, light spindle demonstration. So I think it's the first time to show that kind of transparent demonstration in the exhibition. It's very rare, I think. Okay, can you see that? So light spindle, come here, okay. Come close to left spindle. Now, edge of chuck, pushing to the workpiece, then correctly chucking, then come back. Okay, then right spindle operation start. This process is a key point to complete workpiece in one multitasking machine. This left spindle operation, right spindle operation. And now edge of chuck and pushing to the workpiece and keep pushing. We use our unique technology here, soft work pusher. So we have motor load detection technology in Nakamura-Tome. That is very unique. And this soft work pusher, we set the torque limit for servo motor. And with torque limit, certain value, the axis is keep pushing to workpiece at correct force. Without this function, with big power, the edge of chuck keep pushing to the workpiece. What happened? What happened, Mr. Sherman?
Workpiece get damaged.
Wow, that is a troublesome, and that's so much risk. Without such risk, it's very safety, and we don't need to make the defeat with soft work pusher. How to set up the chucking, also transferring in this machine?
Roughly set approach position and chucking position.
Normally, without soft work pusher, we need to check certain position of chucking and approaching. It takes a time. However, with this torque limit function, soft work pusher, so roughly set, and then the right spindle chuck and keep pushing the workpiece. It means that this soft work pusher can detect certain position. We don't need to do stressful setup for that. Next process is milling operation. So milling operation key to combine the whole process to one machine. So can we show our milling process? That's a face mill.
Yeah.
Now rotating. So how much the depth?
2 millimeter.
2 millimeter. How much cutting condition?
Rotation speed is 2000. The feed rate is 0.2.
It's a powerful milling operation.
Yeah.
Is this race? It's like machining center operation in turning machine. Of course, you can do small diameter end mill. You can do many pass and make it flat. However, when you use that face mill tool for the milling, you can do short number of the machining pass. So you can shorten the machining time. And next end mill operation. Oh, what the movement? Is this 3-axis milling?
Yeah. Helical milling.
Helical milling. It means the 3-axis X, Z, Y-axis milling process. And we have the 3-axis. This milling process use all 3 axes of AS-200L. Of course, we can use bigger diameter and we can do drilling operation for this hole. However, if you use the small end mill, also we can do helical machining and make bigger diameter of the hole. And of course, you can do helical tapping in this machine. We deal with this wide variety of process. So, we look at this compact turret. Compact turret, also high torque milling operation. Normally, bigger turret, also bigger motor. I think for designer of the machine tool builder, I think that's super easy job. However, what the difficult and what the important, what the easy to use for customer, compact turret and high torque milling. Compact turret, it means easy to use. Small risk of collision and also reduce the limitation of the machine. For example, when you travel that small turret to edge of chuck for cross mirroring operation, so it's low limitation. If you have the bigger turret, it's troublesome. It's always need to very stressful operation and sometimes need offset tool. That is our design philosophy. Easy to use, high machining capability. Next is Mr. Ishiyama love this function. What's the name of that?
Cut and check.
Cut in check. Wow, that's easy to memorize. So, can you see the cut in check function, Mr. Ishiyama? Okay, now start operation. So, now facing the workpiece, and then Mr. Ishiyama presses the cut in check button. Okay, then keep doing the machining for the face of the workpiece. Now it's done. Oh, now stop in G00 signal. Start of next operation. So it means when you check the machine condition, when you check the workpiece condition, when you check the cutting chips and tool condition, you are in the machining. Sometimes you need to check and open the door. Normally, you press the feed stop button. You are in the machining when you press the feed stop button. It have the risk of defeat. When you use a cut and check, when we push during the machining, machine keep moving and non-stop the machining, and then after the machining, they stop next to G00 signal. That's a very safety. Mr. Ishiyama, press button again. Okay, now spindle rotate. Okay, press start button. The next machining process start. Wow. Normally, when you stop the machine, you need to set the cursor to your ideal position. But when you set the cursor, it's a risk to do mistake. And then sometimes the risk of collision. Also, when you reset, you need to start front line of program. It takes time and you need to keep waiting. That is a waste of time. So this is a very ideal restart, easy to use. Next function is the digital chuck interlock. We developed many functions, but I love this function the best. When you change the stroke of the jaw, normally we need to uncover this sheet of metal, then we need to adjust sensor and cover again. It takes a time. Also, it left and right spindle, it means double opportunity to do setup, so it's very tough. Now we have digital chuck interlock. So open the door and now rechucking the workpiece. And what the setup in digital chuck interlock screen? Just press a button. It's totally different. It's very easy. Please look at the screen. This I/O change, it's mean ID OD change. For example, when you change power chuck to pallet chuck, so that inside the structure also different. So we need to change the setting. Normally, we need to push many buttons. We find parameter setting screen and change the parameter. It takes a time. However, in digital chuck interlock, in just one screen, we can touch it. Finally, I want to show you one more. I have the two workpiece. It's the same workpiece. So this workpiece is made in morning. This workpiece is made in the night time. What the difference of this diameter? Just 4 micron. It's very accurate. Of course, it's a temperature change. If in the morning and the midtime, it's a need a thermal control. We use AI for this thermal compensation. Of course, we achieve nice thermal control in mechanical. So we design nice structure for the thermal. However, also we have the combination of thermal compensation system. In many countries, of course, in the summer and the winter, temperature are different. Right? If the temperature gap are so big, so customer requests a tuning for thermal compensation. Used to be, we dispatch our engineer and send the data for Nakamura-Tome headquarters. Our designer calculates the parameter. However, now in NT Thermal Navigator AI, when you put the data here and then analysis button, the AI calculates all parameters, all analyze that kind of data and make perfect setting for thermal compensation. Everybody, today we show 4 functions: soft work pusher, cut in check, digital chuck interlock, NT Thermal Navigator AI. All these 4 unique technology, it's a standard for this machine. So you don't need to select expensive option. You don't need to worry about that. Everything you need to start multitasking machining is all set in AS-200L. So it's a best machine. This catch copy, AS-200L, have your first step in multitasking. Okay, everybody, please experience your first step multitasking AS-200L in your factory, and let's cut the burden of manufacturing, enjoy manufacturing together. If you like this video, please subscribe and press high rating. See you, machinists. Bye.